Hi everybody, this is Mr. Folly and my dog right now. Her name is Penny, and she's not very good at chemistry though. And we are going to knock out the rest of this thing. Sorry it took so many. Calculate the standard enthalpy change, delta H naught, for the formation of 1 mole of strontium carbonate. There's 1 mole of that. So that could even have the F. This is actually going to have the F because elemental form. The material gives the red color in fireworks from its elements. This information is available. So I know I want to make SrCO3, so I want this to be just like this. So this is going to be my first one. So, I like to call these 1, 2, 3. So the first one, I'm going to leave it just the way you are. Don't go changing to try and keep me, or whatever it is. I forgot. Now I got that dumb song stuck in my head. So that's the first part. I know oxygen's in a bunch of them, so I'm going to do that last. I want solid strontium on the left. So that means it's going to be this guy right here. I'm just going to keep him. Notice how I've got a 1 coefficient, a 1 coefficient. So that's good. Sr plus 1/2 O2 is going to give me SrO. Hey, look, those already canceled out. Oh, and these two are the same so far. So -5, 2, -2, 34. And then the last one is graphite. Hey, that's nice because it's just, I don't have to do anything to this one either. My goodness gracious. Carbon plus O2 yields CO2. And that's -394. A rare one where I don't have to flip anything or multiply anything. So let's see what we can get to cancel out. CO's on opposite sides. This is going to be 1.5 oxygens. Hey, that's what I want, is 1.5 oxygens. 1 strontium, 1 carbon. We're good. So if I do all this and I add it up, clear, -592 plus -234 plus -394 is -1220. And that's going to be kilojoules. Next. Here we go. I've got a big circle here for no good reason. Let's see if I can get rid of it. Winning. In designing a chemical plant for manufacturing the plastic polyethylene, you need to know the enthalpy change for the removal of H2 from C2H6 ethane to C2H4. A key step in the process. So this is what we're trying to figure out. This is our goal. From experiments, you know the following thermochemical equations. So I'm going to try and make plain old hydrogen first. So see how this is what I'll call first. Well, I guess I should call them 1, 2, and 3. That way I can refer to them. So for 3, what I have to do to get 1 hydrogen is I have to flip it and divide by 2. So I'm going to write that over here. So I'm going to have H2O yields H2 plus 1/2 O2. And that's going to be, I'm flipping it, so positive, 571.66 divided by 2 is 285.83. And then the next one, so I've got my hydrogen done. I'll make my C2H4 next. Here's C2H4. I want 1 of them, so I have to flip this bad boy. So I'm going to have CO2 plus, I didn't divide it by 2, so 2 CO2 plus 2 H2O yields C2H4, what I'm looking for, plus 3 O2s. And that when I flipped it, so its charge is going to change. That's positive 1410.9. Then I have the last thing I want to make, C2H6, which is right here. I have to divide this by 2. It's on the left like I wanted it to be, but it's got to divide it by 2. So C2H6 plus 7/2 O2 yields 2 CO2 plus 3 H2O. I'm sorry, I'm putting these in the weird spots here. But that one I had to leave it alone, right? I just left it alone? No, I had to divide it by 2. So -3119.4 divided by 2 is -1559.7. And then I'm going to combine all of these. I know I did this backwards, but I did it in the order that I did it in, right? So this was the first one I used, and then the second and the third. So -1559.7 plus 1410.9 plus 285.8 is 137 kilojoules. 70. Combustion of carbon monoxide is represented by the equation above. Bum, bum, bum. There we go. Determine the value of the standard enthalpy change delta H reaction for the combustion of CO. So I want to have CO2. I want to have one of these. This is good. I want to have a CO on the left-hand side, so I got to flippity do it. And that'll do it. So I'll check to make sure it balances, but it does. So I'm going to flip this guy, so I'm going to have positive 110.5, and this one is fine, which is negative 393.5. 110.5 plus negative 393.5 is negative 283 kilojoules. Whoops, I put KK. Don't want KK. Sorry to all you people abbreviated KK. Erase, I say, erase. Consider the two processes represented below. For each two processes, identify the types of intermolecular or intramolecular attractive forces that must be overcome for the process to occur. So for this one, you have to overcome, overcome H bonding to boil. So notice how that's a physical change. A physical change is going to be an intermolecular force if it's covalent. Okay, this one right here is splitting the bonds apart. So number two must break H to O covalent bonds. So going process 2 requires much more energy than process 1. So first of all, covalent is closer, and the charges involved are nuclei, which are more attractive than H bonds. H bonds, this is polarity attraction. So even though we know H bonds starts intermolecular force, the plain old regular covalent bonds are stronger. So if I were to bond energy, we're talking about polarity, partial polar, versus the nucleus and electron, and then radius, covalent, much closer. That's it. So hey, out here in pretty decent time. Toodles.